is knowing what a reciprocal function is and how to graph a reciprocal. So let's start to understand what we mean by that. So the topic today is reciprocal functions. If you had the equation y equals x, that would be a slanted line. If I said, what's the reciprocal of y equals x, what would you write down? No, that's the inverse. The reciprocal of y equals x would be y equals 1 over x. So, when we're saying reciprocal, do you know where that comes from when we say that word? The reciprocal of x is 1 over x, and that is what we're going to graph today. So, let's fill this in and let's do the graph together. So the type of graph this is a type of rational. It's a special rational. Now the domain, range, and asymptotes we'll talk about as we do the graph. So let's do a little table of values right in here. There's just enough room to squeeze in a table of values. If you don't know what the graph is going to look like, why don't we start with some values that would help us? So can you think of one good x value I could plug in to know a point off my graph? 0. I'll start there. What do you think it means when you plug in 0 and you go 1 divided by 0? 1 divided by 0 is what? So then the question is, when something is undefined, how do I show that on a graph? It's not a point, not a line, not anything. It's like it's undefined. You can't. It's like a barrier, a wall. How do I show that on a graph when something is undefined? And the answer is, I need to do n. And if that's a new word, I think with last year with exponentials, you said the word asymptote. So it's a fun math word, right? And the word asymptote means undefined. So if you see an asymptote on the graph, that's where it is, undefined. So over 0, I'm going to draw a broken line. I'm making it red so you can see it. So those that love color can make that color happen. So I did a broken vertical line. Do you see that broken vertical line? It's hard to see when it's over the axis. But when we graph and what is undefined is not at 0, you'll see the broken line better. So let's back up. What is an asymptote again? On a graph it shows where the function is undefined. Asymptote, undefined. Asymptote, undefined. Alright. It's not going to touch it, not going to cross it. It's like a wall, barrier for the graph. Back up again. Let's pick a x value we can actually plot. 0 was something that's undefined. Think of any nice x value. 1 divided by something. So 1 divided by 1 is? Beautiful. Can you find 1, 1 on your graph? There's only one other x value that doesn't give you a fraction. Negative 1 gives you what answer? So can you find negative 1 and negative 1? Now, everything else is going to be a fraction. Either you're going to start with a fraction or your answer is going to be a fraction. There are no more integer values in terms of one or the other. So let's say I start with an integer like 2. What happens when I put 2 and what's the answer? So can you find 2 and 1/2? What happens when I put in 3? What's the answer going to be? 3 will give you 1/3. Now, I'm not going to make you do this over and over again, but I want you to think. You ready? To think? What happens when I put in 4? What's the answer? Good. 100. 1 over 100. 1 billion. 1 over 1 billion. Try to think of a number that will give you the answer 0, and you can't. So, the bigger the number I put in, the smaller the answer, but it will never, ever, ever, ever be what answer? So because it will never, ever, ever be that answer, that's also an asymptote, but this time it's a horizontal asymptote. So what answer can you never, ever, ever get? And the y coordinate is the answer, right? And the answer can never be 0. So guess what I need over 0 is what? Another asymptote. And it's hard to tell because it's over the axes. It's a broken red line. So why did I put an asymptote over there? Because the answer can never be 0. No matter what number you put in. It's going to get closer to 0, but never, ever, ever be 0, right? It's like the most saddest love story of all time. That it gets closer and closer and closer and closer and closer and closer and closer, but they never, ever meet. Like Lifetime, but they never meet at the end of the movie. Ever. Like they always get closer and closer, but never meet. One's at the post office, one's at the bank, never meet. Sad, right? That love story. So, what do you think happens when I pick a number between 0 and 1? So what's going to happen when I pick 1 over 1/2? Or 1 over 2, I mean. So what's 1 over 1 over 2? Do you remember how to divide fractions? What do you do? Hey, it's called a what again? A reciprocal. What's the reciprocal of 1? What's the reciprocal of 2? What's the reciprocal of 3? Get why it's called reciprocal? What's the reciprocal of 1/2? So can you find 1/2 and 2? Now, I'm not going to make you do this, because I just want you to know the direction of the curve. What happens when I put in 1/3? What happens if I put in 1 over 100?
100.
1 over 1 billion.
1 billion.
Get the idea? Guess as this number gets closer to 0, is 1 over 1 billion really close to 0? Is 1 over 1 trillion really close to 0? How about 1 over quadrillion? Get the idea? See, as it gets closer to 0, where is it going to? Infinity! Could you ever get there, right? So no matter what fraction I put in and do the reciprocal, it's just getting bigger and bigger and bigger and bigger, but it'll never get there, right? Infinity? So, what's the curve going to look like here? Where's it going? Where's it going? Whoop, and beyond. And then, as you go to the right, what is it getting closer and closer to? The love story, but never, ever, 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 ever meet. Closer and closer and closer. Sad, right? So, there's the curve in the first quadrant. Now we got to understand, what does a curve look like with negative numbers? So now we know why it's called reciprocal. Because whatever number you put in, you do the reciprocal, right? So when I look here and I want to do negative numbers, what happens? What's the reciprocal of negative 2? No, not the yawn. It's negative 1/2. So at negative 2, where are we going to go to? Negative 1/2. What happens if I put in negative 1/2? Like a number between negative 1 and 0. What's the reciprocal? And then, can we just understand the direction of the curve? So, if I put in negative 100, what's the answer? Negative 1 over 100. If I put in negative 100,000, it's negative 1 over 100,000. If I put in negative 1 billion, it's 1 over negative 1 billion. What does that tell you? It's getting closer and closer to 0, but from underneath, right? So this is also that love story. That it's getting closer and closer and closer and closer to what number? So both ends are getting closer to what? So you would say the end behavior, where's the right end and left end, what is it getting closer and closer and closer to? And you say both ends are getting closer to 0. Not a polynomial where we said it went to infinity or negative infinity. This time it's going to 0. What happens in the middle of the graph? What happens when I put in negative 1/4? Or negative 1 over 100? Or negative 1 over 1 million? What is it getting closer to? Negative infinity. Have you ever graphed something like that before? You're welcome, right? Brand new. Beautiful. So there's the curve of a reciprocal. So what do I want you to know from the curve of a reciprocal? Listen. How many asymptotes are there? Which are the two values? When x is 0 and when y is 0. What is the end behavior? How is it curving on the ends? What number is it getting closer to? Good. And what's the behavior at the vertical asymptote? Where's the curve going at the vertical asymptote?
0.
Or?
Negative.
Got it, right? Those are the things we're going to talk about when we curve this. We don't need a lot of points, right? What we need is a point to curve through and know where the ends are going, because the rest are decimals and fractions and all that. So we're going to find a point, and we're going to see where the ends are going, and then we're good. Do we know where the asymptotes are and so on? Anyway, domain. Is this all real numbers, or is there a value x cannot be? Is there something that makes the function undefined? Yes. And what would you say it is? So I'm going to tell you a symbol for all real numbers. It's fun to write down. So the domain, first of all, is all the numbers. And then we say, but x cannot equal what number?
0.
This is a math symbol. It looks like the letter C, and then you make an E out of it. So if you drew a C, and then make it look like an E, and then this big R is for real numbers. So in other words, x is an element of all real numbers, but x cannot equal 0. That's a short way to be able to explain it. It's more challenging to write it in interval notation. If you wrote it in interval notation, the domain would look like this. It's good to know both ways. That it would go from negative infinity to what number? 0. And then we'd have to do a U. You know what that U means? And then 0 to infinity. They mean the same thing. On Alex, they might ask you to do it in interval notation. From negative infinity to 0 and 0 to infinity is another way of saying that all numbers but 0. How about the range? What can the y not be? Same number, which is? And you would say the same thing for the range. It would be the same thing from negative infinity to 0 and 0 to infinity if you had to do it in interval notation. This also tells you the asymptotes. Now for an asymptote, you don't put a slash through it. You just say what it is. Where's the asymptote? At x equals 0. Where's the horizontal asymptote? At y equals 0. All right. This is called, what we just did is called the parent. How we're going to graph these is, we're going to start with the parent and transform to the function we're looking for. So, this is the standard form of a reciprocal function. It's y equals a over x subtract h plus k. If it is reciprocal, the numerator will be a constant, the denominator will be a linear, and you might have a number adding or subtracting that's a constant. H inside the function is the horizontal shift. What direction is horizontal? Left, right, or up and down? Now, this one's always the challenging one. Do you remember doing any transformations last year where you understood if it shifted left or right, up or down, stretches, compressions, reflections? Yes, but it's been a long time, right? So I'm going to tell you something simple. If it's inside the function, in this case, if it's reciprocal, if it's in the denominator, it's the inverse of what you see, like a 0. So if you see a negative, it's actually going to the right, and if you see adding, it's actually going to the... So if it's plus, what direction is it going? Left. If it's negative, what direction is it going? Okay? That's going to take practice to remember that when it's in the denominator, it goes in the opposite direction. How about this part? K, do you see a number adding or subtracting outside the fraction? It does what it says. So K is the vertical shift. It does what it says. So if you see plus, it goes up, and if you see subtracting, it goes down. Next, do you see a constant in the numerator? If it's negative, the function is reflected across the x-axis. So, in other words, if I said, what quadrants is the curve in for 1 over x? You say quadrant 1 and quadrant. If a was negative, when you reflect, it would now be in 2 and 4 rather than 1 and 3 with practice. All right, the absolute value of a greater than 1, meaning don't worry if it's negative or not, just the big number. If you have a big number in the numerator, it's a vertical stretch. So the absolute value just means, don't look at the negative. The negative means reflection. Just know, is the number bigger than 1, or is it between 0 and 1? So if it's a fraction between 0 and 1, it represents a vertical compression. The only reason we do notes is because you can forget, right? So where is the vertical asymptote? You look at the denominator, right? What's the 0 of the denominator? It's when x equals what? H. Where's the horizontal asymptote? It's what k is. And it's y, right, for horizontal? So it's y equals k. And if you don't see a number, adding or subtracting, the number you don't see at the end is 0, right?
Yes.
All right. Let's see if we can actually write reciprocals, and then we'll graph reciprocals. The reciprocal parent function is what? Reflected across it. Then translated 4 units to the right and 3 units down. Write an equation of the new function. So let's write this down. It's a reciprocal, so I'm going to draw a fraction line. And we're just going to go one at a time. If it's reflected, how does that affect the numerator? If it's reflected, what does that mean? What is A is what? Negative. Do you see a stretch or compression? No. So it's just negative what number? But if you don't see a stretch or compression, it just stays 1. So it's negative 1. What's the next thing you know? It's 4 units in what direction? To the right. Is that adding or subtracting in the denominator? Correct. The opposite, right? And then 3 units down. Does it do what it says? Or the opposite? So, on the outside, what am I going to do? Perfect. Let's look at number 2. 3 and 2. 2 first. Read it. Annotate it. Let's write this function down. If you need to wait for me, you can. But if you are getting a sense of the information given that you could write it down, then do it. It's been vertically stretched by a factor of 2. It's been shifted 7 units up and 1 unit to the left. Oh, I didn't do the asymptotes. I'll go back and tell you the asymptotes. But let's do this one first. If it's been stretched vertically by a factor of 2, what's in the numerator? 2. If it's going 7 units up, is the 7 in the denominator or outside? You got to fill in more than that, right? Time and everything. Did you do it? Yeah. All right. So, the plus 7 is going to go where? Outside. 1 unit left. So what, if it's left, is that adding or subtracting? And again, that, right? And I forgot to do this, but we'll do it now. Can you tell me what the vertical asymptote is for number 2? What can x not be?
Negative
Good. And can you tell me what the horizontal asymptote is? What's K? Sorry, K. Okay. It's in my head. 7, right? Let's try it again. So vertical asymptote, horizontal asymptote. Do you know where to look to know where the vertical asymptote is? You look in the denominator, yes? What's the 0 of the denominator? Good. For the horizontal, is there a constant being adding or subtracting? So the horizontal is -3. All right, you try number 3. Can you write a reciprocal function that's been transformed? Yes, more than meets the eye. Read number 3. I know, Thomas, you'd appreciate that, right? Yes, Justin.
How come when you brought over the -3, it stayed a negative, but when you brought over the 4, it turned into positive?
Good question. In the denominator, it's a horizontal shift, and it's the opposite sign for the denominator.
Oh, okay.
And when it's the vertical shift, it does what it says. So the H, which goes in the denominator, you need to do the opposite sign. And the K, the number on the outside of the fraction, it does what it says. That's just going to take some practice. So try 3. Can you set it up? F at x equals fraction line. And then tell me the vertical asymptote and tell me the horizontal asymptote. Does it tell you there are any stretches or reflections? So I'm just going to put down 1. If the vertical is at x equals -2, what is the denominator? And if the horizontal is at 5, and they're already given, right? Like the horizontal's at 5 and the vertical's at -2. All right, turn the page. All right, let's do some graphing. So graph each function, identify the domain, range, and asymptotes. Here we go. So to start with, we're going to start with the parent. The parent is what we started with, and we're going to write down the 2 points that we're going to transform. So we're just going to take the easy points, which are 1, 1, and -1, -1. We're not going to transform the fraction points or decimals. We also have 2 asymptotes we need to transform, which are 0 and 0. This you have to memorize. 1, 1, -1, -1, x equals 0, and y equals 0. Now, how did our function change? Instead of 1 over x, it's now 1 over x subtract 1. Or 2. So I'll give you a moment to set it up and look at it. When I look at the parent and look at the transform function, what's the only difference between the two? This is the subtracting 2, correct? So I want you to understand this. That if you have a number adding or subtracting outside the function, or a different number in the numerator, that affects the y coordinates. If it's in the denominator, it affects the x. Otherwise, it affects the y. So when I see subtract 2 outside the function, it does what it says. And I take each y value, and what do I do with it? Subtract 2. The x values all stay the same because they haven't been changed. So the x value 1 stays the same. And then what do I do with the y's? Subtract 2. And what's 1 take away 2? And we're going to follow that pattern for everything. The x value stays the same. And the y value subtract 2. And now it's negative. The x value stays the same. But the y value I subtract 2. All right, we're going to go to our graph. Find 1 and -1, and -1 and -3. Those are the 2 points I'm going to curve through. We have a vertical over 0. That did not change. But the horizontal, where am I going to draw the horizontal now? So can you find -2? And draw your horizontal. We're now ready to complete the graph. The end behavior is not going to be 0. Instead, the end behavior changes with the horizontal asymptote. So, at what number is the end behavior now? So the right end and the left end are going to what number? The right end and the left end are going to... And then, what's the behavior at the vertical asymptote? It's either going to go to infinity or negative infinity. So the one on the top right is going to infinity, and the one on the bottom left is going to negative infinity, and you just graphed a reciprocal function. What's the domain? So it's all real numbers, but what's the one number x cannot equal? 0. Right? It comes from here. The range, all real numbers, but what can y not equal? -2. And that comes from the horizontal asymptote. Where's the vertical asymptote? Where's the horizontal asymptote? And we're done. All right, let's do it again. So to graph a reciprocal, I'm going to start with the parents. In fact, I'm just going to write down 1, 1, -1, -1, x equals 0, and y equals 0. That comes from the front page, right? 1 over x, no changes. And now I'm going to transform it. So I'm going to start the graph with 1, 1, -1, -1. Those are called parent points. And then x equals 0, y equals 0. Those are called parent asymptotes from the parent. Parent means the simplest form. No adding, subtracting, multiplying, dividing, nothing. The most simple is the parent. All right. Is there any changes in the numerator? Is there anything adding or subtracting outside the fraction? That means the y values stay the same. No changes. Do you see a change in the denominator? It's the inverse of what you see. We're not going to add 3 to every x. What are we going to do? So 1 subtract 3 is -2. -1 subtract 3 is -4. 0 subtract 3 is -3. Do you see how I just went x, 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 and I changed each x value? -2, -4, and -3. How did I change each x value? I subtracted 3. What did I say about the y values? They stay the same. So I'm just going to write them down again, and they stay the same. We're now ready to graph it. So I'm going to start with my points. So at -2 and +1. The other's at -4 and -1. I'm now going to put down my asymptotes. I have an asymptote at -3. Do you notice how one point is on one side of the asymptote and the other's on the other side? It's a good indicator, right? One's on the right, one's on the left. The asymptote for the horizontal is at 0. Again, do you see how one point is above it and one point is below it? These are like little indicators, right? To know that you're doing it correctly.
Yes.
The horizontal asymptote tells you the end behavior. What tells you the end behavior? The horizontal asymptote. What's the end behavior? The horizontal asymptote. At what number is our horizontal asymptote? So the right end goes where? To 0. And the left end goes where? To 0. So start with the ends. Then what happens at the asymptote, the vertical asymptote? Either infinity or negative infinity. So the one above goes to infinity, and the one below goes to negative infinity. Done. Domain. I'm going to write this in interval notation so you can see both. What's the one number x cannot be? So we're going to go negative infinity to negative 3 and negative 3 to infinity. And that's a different way of writing the domain. Just like for the range, I can go negative infinity to 0 and 0 to infinity. Both are correct. And then write down your vertical asymptote and your horizontal asymptote. All right, number 6. And I'm probably going to do 6 and 7. And I'll make a video on 8 and 9 to finish the lesson. And then I'll do a homework video so you can practice with me for tomorrow's quiz. So number 6. How are we going to start this? We start with the parent points. What are the parent points? 1, 1, negative 1, negative 1. The asymptotes are x equals 0 and y equals 0. Look at the equation. How has it changed? It was just 1 over x. So what's changed? What number do you see in the numerator? And what do you see outside? Do you see any change in the denominator? That means the x's stay the same, and it's the y's that are changing. A negative in the numerator means it's reflected. A 4 means there's a vertical stretch. And plus 1 means it went up 1. We're going to change the points, and you'll see it. So the only thing that's changing are the y's. So 1, negative 1, x equals 0. The x's stay the same because the denominator did not change. For the y's, we're going to do 2 things. And we multiply before we add. So when I look at the numerator, what number are we going to multiply times? Negative 4. And then what am I going to do? Add 1. So what's 1 times negative 4? Get an answer. Add 1. And you got the new y coordinate. This is going to require 2 steps. How about try it again? What's negative 1 times negative 4? And then add 1. Beautiful. One more time. 0 times negative 4. 0. Add 1. And now we're going to our graph. So I'm going to find 1 and negative 3. I'm going to find negative 1 and 5. See how already the points are stretched out vertically? They're not as close together. And then x equals 0 is the vertical. Do you notice one's on the left and one's on the right? Y equals 1. Notice one's above and one's below. It's not as close, is it, to the horizontal? That's because it's been stretched out. Now, what's the end behavior of a reciprocal? Where do I go to? The horizontal asymptote tells you the end behavior. So where's the right end going? And where's the left end going? Do you see how I'm curving it? So the ends are getting closer to what number? 1. What happens at the vertical asymptote? Either goes to infinity or negative infinity. So the one below goes to negative infinity, and the one above goes to positive infinity, and you just graphed it. So what gives you the end behavior again? The horizontal asymptote. So the domain goes from negative infinity to 0 and to 0 to infinity. The range goes from negative infinity to 1 and from 1 to infinity. We said the vertical asymptote and the horizontal asymptote. All right, you got one more before you got to go. Number 7. And then I'll do 8 and 9 if you want to see the last 2 in the lesson. And then I'll do the homework sheet with you. And I'll send out the link. Hey, you want to do your homework with me? Here's the link. Good deal, right? Number 7. How do I start this? What are the parent points that you need to memorize? 1, 1. What else? Negative 1, negative 1. What else? What's the asymptotes? 0 and 0. So, I'm going to look at the denominator. Did the denominator stay the same or is there a change? How did it change? How did it change? So it says instead of x, it's x subtract 2. Do you do what it says, or is it the inverse in the denominator? So instead of subtracting, I'm going to, so to every x value, what am I going to do? Add 2. Let's go. 3, 1, and instead of 0, it's now 2. How did I get that? I added what number to each x value? 2. Do you see something in the numerator? That's what you multiply times. Do you see something outside the fraction? That's what you add or subtract. So to every y value, notice there's a vertical stretch, and it's gone up 2 or down 2. I'm going to go times 3 and subtract 2. What's 1 times 3? Take away 2. Negative 1 times 3. Take away 2. 0 times 3. Take away 2. So now that's what I plot. So 1, 1. No. 3, 1. 1, negative 5. The asymptotes are at 2. And at negative 2. Do you notice one's above, one's below? One's to the left and one's to the right? What's the end behavior? What do I look at? The horizontal asymptote. So the right end is going to what number? And the left end is going to what number? Then, one goes to infinity, the other goes to negative infinity. I'm going to finish this. So x can't be 2, y cannot be negative 2, and we have our two asymptotes. So, I am going to do 8 and 9 on a separate video. And please do the homework. Mr. G Math. There you go.